However, it was pushed away from the sun by some mysterious force. And it was mysterious because there was no evidence for dust or gas that you see around comets. That the evaporation of those gives the comet a kick from the rocket effect, the same mechanism that pushes jet planes. But there was no evidence for dust. It was definitely not a comet of a type that we are familiar with.
What if the first sign of intelligent life beyond Earth has already visited us, and we let it go? In 2017, a mysterious object named Oumuamua raced through our solar system, fast, silent, and unlike anything we've ever seen. It didn't behave like a comet or asteroid. It didn't look natural. It didn't even act like it belonged. For years, scientists struggled to explain it, but the deeper they dug, the stranger it got. This isn't just a cosmic mystery. It might be a warning, a message, or something more. So buckle up, because this story changes everything you thought you knew. A visitor that shouldn't exist. Imagine this: a mysterious object suddenly appears in our solar system, approaching past the sun and defying every expectation astronomers have for natural space debris. That's exactly what happened in 2017, when scientists discovered a strange interstellar object later named Oumuamua, a Hawaiian word meaning scout or messenger from afar. But this wasn't your average asteroid or comet. It moved in ways that didn't make sense. It had no visible tail, no no dust, none of the usual cometary features that would explain the slight push it seemed to be getting from some invisible force. Yet it was clearly accelerating. For years, Oumuamua baffled scientists. Was it natural, artificial, a comet with invisible gases, a flat rock? The mystery only deepened when researchers used advanced star mapping data from the European Space Agency's Gaia mission and combined it with complex models of our galaxy's gravitational forces. Their goal? To track where Oumuamua came from. What they discovered shook the scientific world. Its path traced back to a quiet, young star system in the thin galactic disk, a peaceful region of the galaxy not known for chaotic events that might launch objects into interstellar space. This was the first red flag. Debris from young stars typically doesn't get flung out unless something massive, a gas giant or a binary companion, is around to give it a strong gravitational kick. But none of those forces were present where Oumuamua originated. And the object wasn't just wobbling like a rock, it was tumbling in a complex, energetic motion that suggests it was violently ejected, but from a system that shouldn't have the power to do so. The data started to suggest something far more exotic than a random space rock, too perfect to be random. The more scientists dug into Oumuamua's trajectory, the stranger it got. Harvard astrophysicist Avi Loeb and his team discovered that it was moving in a nearly perfectly flat orbit along the galactic midplane, the dense central zone of the Milky Way. That kind of precision is statistically improbable for a natural object. In fact, Oumuamua's vertical deviation from the galactic plane was 6 times smaller than even our own suns. That's like finding a needle not just in a haystack, but in the exact center of the haystack. But it wasn't just the alignment that raised eyebrows. It was how it moved relative to nearby stars. Its velocity was nearly 0 in the local standard of rest, meaning it appeared to be stationary in space as our solar system moved toward it. That's extremely unusual. Objects flung from stars typically carry high velocities, like fastballs thrown into the cosmic void. But this thing, it was floating like a buoy in still water, perfectly calm, almost like it was parked there, intentionally. That idea alone stirred controversy. Loeb even suggested that if you wanted to hide a probe in space, this is exactly how you do it. Place it in a frame of reference where it wouldn't move much relative to the stars. And it doesn't help that the region it was found in is densely populated with stars, the perfect place to hide in plain sight. A close encounter, too precise to ignore. As Oumuamua drifted closer to the inner solar system, things got even weirder. Natural interstellar objects tend to pass through space without getting too close to any planet. It's just a numbers game. But Oumuamua, it took a path that brought it remarkably close to Earth, and not just by a little, It skipped right past Mercury and Venus, the inner planets you'd expect an inbound object to encounter first, and instead swung closer to Earth than either of them. When scientists ran computer simulations to test how random objects might move through our solar system at Oumuamua's speed and angle, the results were eye-opening. Less than 1% of simulated objects would have taken the exact path that Oumuamua did, and even fewer would have passed that close to Earth. That kind of statistical outlier isn't just rare, it suggests intentionality. Was it just a freak cosmic coincidence? Or was something or someone aiming? These questions are uncomfortable for mainstream science, but they're also unavoidable. If Oumuamua had been drifting aimlessly for millions of years, its sudden precision targeting of Earth makes no sense. It was like a probe on a flyby mission. Not close enough to enter orbit, but just close enough to get a good look, the sail that wasn't there. Then came perhaps the biggest twist in the entire saga. As Oumuamua exited our solar system, astronomers noticed something they couldn't explain. It accelerated, ever so slightly, in a way that gravity alone couldn't account for. Usually when a comet accelerates like that, it's because gas jets, from melted ice, are pushing it like a tiny thruster. That's what gives comets their glowing tails. But Oumuamua had no gas, no tail, and no dust. It was completely inert. Astronomers turned powerful telescopes toward it, expecting to find some kind of outgassing, but there was nothing. So how was it accelerating? Harvard's Avi Loeb and physicist Shmuel Bayali offered a jaw-dropping theory. What if the push came not from jets of gas but from sunlight itself? More specifically, solar radiation pressure, the tiny force created by photons from the sun. They suggested that if Oumuamua were an extremely thin, flat object, like a light sail, it could be getting pushed just enough by the sun's rays to explain its strange motion. Their calculations showed that it would need to be less than 1 millimeter thick, but possibly hundreds of meters wide. That's exactly the kind of structure humans have been testing in recent decades with experimental spacecraft. Japan's Ikaros mission and the Light Sail 2 project already proved that solar sails work. We may not be alone after all. As wild as the Oumuamua story is, what makes it even more mind-bending is this. It might not be the only one. In fact, we may have been visited before, and we simply didn't realize it. Back in 2014, 3 years before Oumuamua's discovery, a tiny object named IM-1, a fast-moving meteor, streaked through Earth's atmosphere near Papua New Guinea. It was officially labeled as a meteor, but later analysis of its trajectory and impact data revealed something unusual. It had interstellar origin. It was moving too fast to be gravitationally bound to our sun, and its material strength had exceeded anything seen in natural meteors from our solar system. Let that sink in. A meteor from another star system crashed into Earth, and it might have been even tougher than any natural rock we've studied. This revelation reshaped how scientists think about our cosmic neighborhood. For decades, we believed interstellar visitors were incredibly rare. Now, it's becoming clear they might be surprisingly common, and we just haven't had the tools to detect them. That's changing, fast. Harvard's Galileo project, led by Avi Loeb, is now scanning the skies with a network of observatories, using AI-powered detection systems to catch objects like Oumuamua before they disappear. These aren't just telescopes. They're a full surveillance system aimed at uncovering interstellar artifacts, a cosmic timeline that doesn't add up. Here's another riddle. Even if Oumuamua was artificial, how could something so advanced come from such a young star system? Based on its galactic path, scientists estimate that Oumuamua is only about 1 to 2 billion years old. That's nothing in cosmic terms. For comparison, Earth is 4.5 billion years old. That makes Oumuamua a cosmic toddler. If it's natural, it should be weathered, battered by cosmic radiation and interstellar dust over time. But Oumuamua appears unusually pristine, with none of the damage we'd expect from billions of years floating in space. But here's the kicker. If it's artificial, the timeline is even more baffling. Think about Earth's history. It took nearly 4 billion years for simple life to evolve into intelligent beings like us. Even after intelligence appeared, it took hundreds of thousands of years to develop technology. And only in the last 100 years have we built spacecraft. So how could a civilization in a star system younger than Earth already launch an advanced interstellar probe? This is what scientists are now calling the age paradox. Either intelligent life can evolve much faster than we thought, or, and this is the unsettling part, Oumuamua didn't originate there at all. Maybe it was built by a much older civilization, and the young star system was just a launch pad, or even a pit stop in a longer interstellar journey. The cosmic odd couple, Oumuamua versus Borisov. To truly understand how strange Oumuamua is, we need to compare it to something more familiar. Enter Comet 2I Borisov. Wow, the second confirmed interstellar object ever detected, discovered in 2019. And unlike Oumuamua, Borisov behaved exactly how we'd expect a natural space visitor to behave. It had a comet tail, it emitted gas and dust, and it followed a predictable gravitational path as it swung through the solar system. NASA's Hubble Space Telescope captured striking images of Borisov glowing with classic cometary features, a bright coma, volatile gases, and the standard icy composition. Everything about it screamed, "I'm a regular interstellar comet." Now contrast that with Oumuamua. No gas, no dust, no tail, strange shape, unexpected acceleration, and a trajectory that seemed anything but random. It was like comparing a textbook meteorite to a stealth drone. Even their origins were wildly different. Borisov's path traced back to a mature star system, the kind of environment that's been around long enough to form and eject comets. In contrast, Oumuamua came from a young stellar nursery, where such ejections shouldn't even be possible yet. As one astronomer put it, Borisov is exactly what we'd expect. Oumuamua, on the other hand, breaks all the rules. Was it watching us? If we seriously entertain the idea that Oumuamua might be artificial, we're left with one huge unnerving question. Why was it here? Let's break it down. It passed unusually close to Earth. It moved in ways that suggest precision engineering. It had no tail, no adamando, yet it accelerated like it had a propulsion system. And its thin, sail-like shape matches designs we're just beginning to experiment with ourselves. So what could it be? One theory is that it was a probe, an autonomous spacecraft sent to observe star systems like ours. Just like we send robotic rovers to Mars and flybys past Jupiter, another civilization might be doing the same, except on a galactic scale. And if that's true, then Oumuamua's trajectory through our solar system, especially its close approach to Earth, may not have been random at all. Another possibility, it's a kind of data buoy, drifting silently through the galaxy, recording and storing information, perhaps waiting to be retrieved by its creators. Think of it as a cosmic USB drive, filled with data about planets, atmospheres, maybe even civilizations, and quietly floating through the stars until something comes to collect it. Some scientists even propose it could be a beacon, a marker placed in our solar system to say, we were here. Its precise alignment with the galactic plane would make it easy to track, especially if other similar objects are scattered across the galaxy. And while no signals were detected when radio telescopes listened in, that doesn't mean it wasn't transmitting. Maybe it wasn't talking to us. Or maybe it only speaks when the right kind of listener is nearby. A name with meaning and a warning. To truly grasp how surreal this story is, we need to go back to the beginning. October 19th, 2017. That's when a telescope in Hawaii, Pan-STARRS 1, spotted something faint, fast, and entirely out of place. An object was slicing through the solar system at a speed too fast to be captured by the sun's gravity. It wasn't orbiting, it was passing through. For the first time in history, we had hard evidence of an interstellar object visiting our cosmic backyard. Scientists named it Oumuamua, a Hawaiian word meaning scout or messenger sent in advance. At the time, it seemed poetic. Now it feels almost prophetic. At first, researchers struggled to define what it even was. Too fast for an asteroid, too inert for a comet. Every time it didn't fit the box, they made a new box. Eventually, they gave up trying to categorize it in traditional terms and simply labeled it an interstellar object. That wasn't just a name, it was a white flag. Oumuamua didn't follow the rules. The scientific community began offering all kinds of exotic natural theories: hydrogen icebergs, nitrogen shards, frozen cosmic snowflakes. But none of these held up under scrutiny. They sounded plausible until you ran the numbers, and they all fell apart. In the face of mounting anomalies, Avi Loeb took a bold step. He said what many were thinking, but few dared to say. What if it wasn't natural? And instead of being dismissed outright, his theory gained momentum, because nothing else explained all the weirdness in one clean narrative. What comes next? Oumuamua is now beyond the reach of even our most powerful telescopes, disappearing into the darkness, leaving behind more questions than answers. But its brief visit has ignited a movement within the scientific community, one that's willing to ask the uncomfortable questions and challenge the old assumptions. That's where the Galileo project comes in. Led by Loeb and backed by serious academic muscle, this initiative isn't waiting for the next mysterious visitor to fall into our lap. It's proactively scanning the skies using AI, advanced optics, and predictive tracking to find anomalies before they vanish. Its mission is clear: catch the next Oumuamua in real time and figure out what these objects really are, and more importantly, what they want. Because if Oumuamua truly was a probe or a beacon or a drifting observer from a civilization far more advanced than ours, then our first encounter with it wasn't just science fiction. It was first contact. Silent, brief, and utterly beyond our control. We may not know who sent it. We may not know what it was recording. But here's what we do know. It was real, it was different, and it was watching. If this blew your mind, don't forget to like, subscribe, and comment your theories below. We dive into space's biggest secrets every week. And trust us, this is just the beginning. Stay curious, stay skeptical, and stay ready for what's next.